Hi, my name's Ken Oakeson and I design and develop embedded systems for SGW Designworks. And today I'd like to talk about some of the boards that you might find used in the development process of a printed circuit board for an embedded device or the Internet of Things. So you may have heard of the Arduino and Raspberry Pi devices. They're used by a lot of people for instructable type projects, and they're also good for prototyping. We like them because they're inexpensive. They come with lots of accessories that can snap on. They're called shields. Those come in different sizes with different capabilities like sensors or lights or connectors. And then the Pi is a full-fledged Linux computer. This is the Raspberry Pi 3. Has all the connectors for Ethernet, HDMI. You could use it like a regular computer. And so it also has powerful libraries that are available to it for things like computer vision, things like that. There's also the smaller Raspberry Pi Zero. It's a wireless computer, much smaller form factor, so it gives us a lot of options for prototyping something. But we typically don't use these in the end product because they either cost too much relative to a custom printed circuit board, or they're not available in the quantities that we might need, or the size of them is too large. So when we get further along in the development process, we like to use a custom printed circuit board, and in the end that's going to have exactly what we want on it and nothing else, nothing extra. And we use the lowest price components that we can, and then connect any sensors or devices that we need to. So to get to this, a lot of times we'll use an evaluation board from a vendor like Microchip in this case, or Texas Instruments. And the evaluation boards typically have the chip on them, the microprocessor, and perhaps a Wi-Fi or Bluetooth connection. This particular one has Ethernet on it. And then it may also have a few sensors or a few buttons or LEDs for testing things out, and then a socket to allow you to connect things like we talked about for the Raspberry, or for the Arduino and the Raspberry Pi. But we can wire in the actual sensors and controllers that we're going to use, see if they work correctly. Once we feel comfortable with that, then we can move to the custom board, and that's something that the programming on this is a little more involved. We call it bare metal programming. It's a little bit lower level than what we'd be doing on these devices, but it gives us the minimum code size, again, so that the chip and the memory can be smaller and cheaper, and that can take us all the way to the manufacturing prototype. So that's it in a nutshell. Thank you.